Hi, this is Polly. Welcome to lesson 2 of the series on learning how to factor quadratic expressions. In this one, we'll look at identifying common factors. Now, what is a factor? It's any one of two or more quantities multiplied together to form a product. For example, 5 times 7 equals 35. That means 5 and 7 are factors. If I have a term that looks like 11ab, then 11a and b are each factors. If I have something where 17, for example, is multiplied times a quantity, like 11ab plus 13, then 17 is a factor, and then that whole quantity, 11ab plus 13, is a factor. In 36DE, I can list all the factors of 36, which you see on the screen, and then D and E are also factors. Now, when we're doing factoring, we want to look for a greatest common factor, a GCF. And that's just the largest factor that's common to two or more numbers or terms. For example, if I look at 10 and 25, the factors of 10 are 1, 2, 5, and 10, and 25 are 1 and 5 and 25. And the greatest common factor there is 5. What's the GCF of 18 and 45? Well, one way to figure it out is to list the factors of 18, the prime factors. So it's 2 times 3 times 3, and 45 is 3 times 3 times 5. You'll see in both of those numbers, they each have two 3's as common factors. So the greatest common factor for 18 and 45 is 3 times 3, or 9. What's the greatest common factor of 12, 20, and 25? Again, I list the factors of 12, the prime factors, which are 2 times 3 times 3, 20 is 2 times 2 times 5, and 24 is 2 times 2 times 2 times 3. What they have in common, they each have two 2's. So the greatest common factor is 4, 2 times 2. I don't consider the 3 because it's not in 20, and I don't consider the 5 because it's not in 12 or 24. What's the GCF of 15x to the third, 25x squared, and 50x? Again, I list them down into their basic factors, including the x terms. So 15x to the third is 3 times 5 times x times x times x. There's 3 x's multiplied, and so on. And you'll see that what they have in common is simply a 5 and a single x. So 5x is the GCF of those three terms. Now, if I added those three terms and I wanted to factor out that common factor, we know that 5x is the GCF, so we'll divide it out of each term. 15x to the third divided by 5x is 3x squared. 25x squared divided by 5x is 5x, and 50x divided by 5x is 10. So let's factor out the common factor in 18x to the third minus 24x squared plus 12x. For the numbers, I know the greatest common factor there is 6, and if I look at the variable, the greatest common factor is just a single x. So if I divide out 6x from each of the terms, I'm left with 3x squared minus 4x plus 2. I get that because 6 times 3 is 18, and so on. Now if I factor out the common factors from something that looks like this, 5x times the quantity 2x plus 1, plus 4 times the quantity 2x plus 1. In each of those terms, I see a common factor of 2x plus 1. So I could factor that out front, and then what's left is the 5x plus 4. So the common factor there is 2x plus 1, and what's left is 5x plus 4. And this is going to become important when we learn how to factor by grouping in the next lesson. Let's try one more. 7x times 4x minus 3 minus 4 times 4x minus 3. Now, in each of those two terms, I see a common factor of 4x minus 3. I'm going to write a 1 in front of the second term because it's understood to be there, and that will remind me that I need to have that 1 when I divide out the 4x plus 3 from each term. So I'll write the 4x minus 3 out front, and what's left is the 7x minus 1. So you see where that 1 comes into play, even though it wasn't written in the original problem. Now you're ready to complete the practice problems for set 2 and check the solutions, and I'll see you in lesson 3.